Hi guys, welcome back to my YouTube channel. Today we are going to solve GFG 160-day challenge problem Day 10, that is Kadane algorithms, and this is the medium level problem. So let's see the problem. So basically, Katani's algorithm efficiently solves the maximum subarray sum problem, which aims to find the contiguous subarray with the largest sum in a given array. Right? So this algorithm uses a dynamic programming approach to reduce the problem complexity to order n. We can also solve the in order n square, but we have to take care about the our expected complexities like time complexity order n and auxiliary space order of 1, right? So if we will use the for finding the maximum subarray uh, sum, so we have to use Kadani algorithms. Okay, so let's read the problem statement. So we have given an array R, and you need to find the maximum sub array, maximum sum of a sub array. Okay, so we have a given example input like a 2 3 minus 8 7 minus 1 2 3. So if we calculate the maximum sub array, and then we have to take the sum. Okay, so like this, if we have a just it could be have a negative and positive values both, and we have to find the maximum sub array sum, not maximum sub array, not maximum sum. Okay, so don't be confused here. So let's see like how we are going to approach this problem. So I'm going to take a board on board. So the idea is like just at any index I first I'm going to take this example 2 3 minus 8 7 2 3. Let's take array 2 3 minus 1 7 and minus 1 2 3. Again minus 1 2 3. Let's check again 2 3 minus 8 7 minus 1 2 3. 2 3 minus 8, this will be 8. Okay, 2 3 minus 8 7. Okay, so the core idea is like at any index I, so at any index I, just there are two choices, right? So like first choice is include the current element in the sub array that ends at I minus 1. Okay, so first let's understand like what is sub array. Okay, and there is a word like contiguous sub array. Okay, so sub array, what will be the sub array of this array? So just first elements, it's a sub array, and then these two elements, this is also sub array, these three, then this four, this one and the whole array. So then again we have what should be the sub array, this one, then this one, then this one, then this one, and then again this one, this and this. So like this, then these one, then these two, these three, these four, and these five. So like this, then again this will be. So like this we have a sub array we can calculate. So what is not the sub array? Like if we have element, then again I'm writing 2 3 minus 8 7 minus 1 2 3. What is not the sub array? We are taking this one and then we include this one, because this is not our contiguous subarray. Contiguous means uh, every element of the array is storing just next to it. Okay, like there is no gap. So this will be the contiguous array. But here if I'm taking 2, 3 and then 7, I exclude here minus 8. This is not subarray, right? This is not our subarray. And then again we can have like minus 8 and then 2 and 3. This is also not our subarray. What will be the subarray? It could be any number but the contiguous. Like 2 can be subarray, and 2 comma 3 is subarray, and then 7 minus 1, 2 is our subarray. We can say 7 minus 1, 2, 3. This is also subarray. So first clear these two concepts, like what is a subarray, and then like what possible uh, could be the subarray. Okay, so what is idea here? First we will check like the first number, like 2. We can consider this is I our. Okay, include the this element in the subarray that ends I minus 1. That means previous one. If I'm taking 3, so I'm talking about the 2. Okay, so if we will add these two numbers, if we will get the maximum subarray sum, then this will be the answer. Then again we will add this like minus n. If we will get the maximum sum of this subarray, like 2, 3 minus n, so this will be the our result. But if we will get the negative values are less than this, less than the our sum, I will explain the algorithm also. So this will be the our then we will discard it and then start a new subarray with the current element. So the decision depends on the whether adding the current element improves the sum or not, right? So if some of these two numbers will increase, then we will take it. If decrease, then we will discard it. Then again we will start the new subarray, like 3 and minus 8. If we will get the positive numbers and greater than the previous element, then we will take it, otherwise we will discard it. Okay, so let's first I'm going to write the algorithm steps. Okay, so what is the steps here? So first we will initialize with two variables, and two variables like we can name it like max ending here. That means maybe our maximum sub array is 2 only. Okay, then the second variable we can say like maximum sum, or we can say like maximum so for. That means when I'm taking only two sub array, so its maximum sum will be 2, right? But when I'm taking like these two this sub array, like this one, then the sum will be 5. So 5 is greater than 2, then I'll consider it. Okay, so these two variables I find it. First I will find this one, then I will add, then I will get sum, do the sum, and if sum is greater than the previous one, then we will consider, otherwise I will discard it. Okay, so and the second step is like I will iterate through the array, like for finding the next element. So we are not finding like here just sub array. For this one we will store also the like starting index and the ending index. But our goal is like maximum of sub array, not sub array, maximum of sub array sum, right? Maximum sum. So I will iterate it and then compare the maximum sub array sum ending at the current index. Like this variable max ending here I will take what will be the maximum error of I, and what initially I consider ending here plus area of I. That means what will be the 2 and 2 plus 3, right? Then 2 and 5. So max of this. So I'll consider 5. Okay, like this I will iterate through the array total. What is it? So, like if adding the current element improves the sum, so we will continue the subarray. Otherwise, we will start the new subarray. So in this case, in this case, 2 plus 3 is 5. Then I'm adding minus 8. So 5 and minus 8. We will get minus 3. So minus 3 is not greater than 5, right? It's not greater than 5. 5 is greater than minus 3. So I will discard this one. Then again I will not carry forward these two numbers, because uh, we will leave the gap. We will not consider that gap for the contiguous subarray. So then again I will start the new subarray. Then I'll consider 7 from here, like. So if I'll check with like minus 8 and 7, then I will get minus 1. Then again I will not consider this one. Start with 7, right? So if I'll start with 7, then minus 1, I will sum these two numbers, then I will get the 6, right? So this is the positive, and then I consider it. So then again I will add these two numbers. So 6 plus 2 is 8, so it's greater than earlier one, so I'll consider it. Then plus 3, so 11. So this subarray is the maximum subarray sum, right? So then again I will return the result if I'll get the maximum subarray sum. Okay, so this is the algorithms, and this is the approach we are taking. Let's jump to the implementation part. Okay, so first, what is the first step? First step, like we have to take that two variable. First variable is for summing the summation of the sub array, and second array is like we are iterating through the array. Then we will consider like, oh, what are the elements we are adding in that variable. Okay, so max ending here. So first we will consider like our first element is the our maximum subarray. Okay, and max. So for then again we'll consider this is the maximum sub array, right? Then second step was like we have to iterate through the array. So for I in range 1 to length of array, and then max ending here, we will take the max of two numbers. First one is the previous element, and the second is the previous elements plus existing elements taking the sum, right? So maximum previous elements is our I, and max I'll copy this means I minus 1 plus current element. The current element is our arrow of I, right? Yeah, so I'll take the max. Then we have to find the maximum so far also. Maximum so far. Then again we will max so far, because every time we are updating it, right? And max. So every time we are updating it, then we will just return our maximum so far. Okay, let's compile and run. Int object is not maximum ending here. Okay, I mistake here. Duplicate is not correct, right? Because this is the number. This is not the our array of the element. This is our n number we are calculating. We initializes, right? So by mistake I took that. Sorry guys. Maximum ending here is not defined. Um, okay. Yeah. So our output is also 9 and expected is also 9. Okay. So let's submit. Let's check all the tests will pass or not. So all the test cases are passed 11 by 11:15 by 11:15. Yeah, so this is the approach that we have taken. So I hope you understand the Kadani's algorithm with the implementation. If you don't get it just in one go, so please rewatch this video. I hope you will understand this. So yeah, thank you so much for today. I will see you in the next video. Okay, keep learning and keep growing. Thank you. Bye bye.